rest of the alcohols and carbonyls. And here I have, let me see here, first thing what we have to do. Identify the class of compounds. How do you identify the class of compounds? You have to see the carbonyl functionality. If you remember, I said carbonyl has two versions of it. So there's C double bond O in the middle of a carbon chain, and also and the other one is carbon C double bond O and a hydrogen also hanging. It has to be a terminal, or it's actually the first carbon gonna get like that. So in this case, I would say, see the hydrogen, so this should be L, or it's the ending name, but you can say aldehyde, right? And then if it is sitting in the middle anywhere, that's called the ketone, right? Okay, so now the keto food, that term comes from that one actually. Okay, all right. So the class of compounds, by looking at it, I can see this is a CH3 functionality, right? I mean CH3 group, and this is a CH3 group, and this is a CH3 group, and this carbon has one hydrogen sticking out. This carbon already has all four bonds, so it looks like a ketone. So the class is ketone, right? And then here the same, it's a ketone, right? And let's look at the last one. You have this situation, right? And C double bond O and a hydrogen, so it's the first carbon actually. So this one is an aldehyde. Okay, now let's do the naming, right? So to do the naming, let me clear this one so you can see clearly. Okay, and so you want to get the functional group to, within the main chain, and select the longest chain including the functional group, and give the lowest number possible for the ketone. So that means 1, 2, 3, and 4, right? So and it's a ketone. I should say this is butane, and it's at the second position, 2-ONE, butanone. Butane 2-on, you can say 2-butanone. So both are good. Okay, so now what I have is a methyl here. It's a CH3 group hanging at the third position, so I should say 3-methyl, right? So again, for clarity, you can break it down. 3-methyl is a substituent, butane is the longest carbon chain, and second position has a ketone. Okay, that's how you want to do it. So let's quickly do this one here. And again, so here's the functional group, and then should be lowest number. The longest chain is as obvious here, 1, 2, 3, 4, 5. So it's 2-pentanone. So you can say pentan 2-on, pentan 2-on, right? But if you write it 2-pentanone, that's perfectly okay, pentanone, right? Okay, now this one is simply called, it's a benzene ring, just know it's benzaldehyde. And similarly, we have benzoic acid, and so on. Okay, so let's do this one here, draw methylpropanol. Now I'm kind of going backward, right? So so what I need to do, propanal, right? Propanal. Propan is 3 carbons, 1, 2, 3, right? And if it is an aldehyde, it should be the first one. So if it is an aldehyde, I should have double bond O and a hydrogen, and it should be 1. Then that means 2, 3. So that's propanal actually, right? But what's missing is 2-methyl. In the second position, I should put a methyl group. So I can have a stick here that shows methyl, or you can also say CH3, right? So that's how the 2-methyl propanal should look like. And then let me put the hydrogens for you to see. For the third carbon should have 3 hydrogens, and the second carbon should have 1 hydrogen, and the last carbon already 4 bonds satisfied, so that's okay, right? If you write it the condensed formula, it would look like CH3 CH3, CH bracketed CH3, that's this guy, okay, the substituent. And then you should say COH, you can write, okay, that means that one. Okay, that's how you write it, right? Actually it should be written not OH, it should be HO, CHO. That's how we write this group. Okay, all right. Oh, that's yeah, this is the line angle diagram, but I need to have a hydrogen here. Do you see that? I made it how I made it. So that's the same thing. So you practice a couple of times on that. So I put it there for clarity. Okay, the two reactions I think I'm going to teach here. Let me see here. First thing, notice, complete the given reaction. Platinum, that's the catalyst, right? And then I have hydrogen here, so I'm going to put the hydrogen as hydrogen is added. So I would say here this bond is pi bond. Always there's sigma bond first one, and then the second one is a pi bond. And then I'm going to put the hydrogens here, and then all we do, the catalyst helps to break and make bonds. It breaks that bond, it breaks the pi bond, and this goes here and this goes there. So I'm going to copy the carbon skeleton. So 1, 2, and including the oxygen, that's the carbon skeleton and the oxygen, right? I just copied it. And then I'm going to stick the hydrogen here and the hydrogen here, right? Now that's the correct compound, right? So what you had is a ketone, the class of compounds. What you end up with the secondary alcohols. You see whether I'm correct. And you can name it too, practice to name it too, right? Now I'm going to add few more things here though. So I'm going to complete the hydrogen so you can see that one. So this one is a CH3, this one is a CH2, this one is a CH, right? But it has an OH sticking out here as a, it's the functional group actually. Then you have this one is a CH3. Okay, that's how it should be written in a condensed one. You have the line diagram too. So let's see what's this reaction. Here the water is kicked out, water is emitted. So that kind of reactions are called dehydration. Know the term. We learned hydration at the beginning of this video, the last video actually. So dehydration, right? So that means removing of the water. Hydration means water addition, and D means removal of water. So, and then this is a catalyst, right? This is acid catalysis. And that's what this one, just like the platinum, right? And then so I'm going to put the water molecule here, and this water molecule, sorry, no, I'm not going to put the water molecule. What happens is this, because it's a dehydration I'm talking about, right? So now I can see there is a hydrogen sitting here, right? And then if I keep it that way, what can happen, and there is 2 hydrogens here. Okay, what can happen is water molecule can be eliminated this one with one of these. That's called the elimination. That's how you get this water. So now as it goes, it breaks this pi bond, sigma bond, and it breaks this sigma bond. These two going to make a new bond, a pi bond. So I'm just going to draw it like that's the new bond made as the water molecule is being removed or dehydration. So the rest of the skeleton I'm going to copy sigma bonds, right? And then one here, right? So that's what that one is, right? So I ended up with this case a butene, right? So so you start with the secondary alcohol and you end up with the ketone in this, sorry, alkene. You end up with an alkene. right?